In this video, I'll talk about network services. Network services listen on a TCP or UDP port number for connections. So, for example, with a client DNS query where a client is contacting a DNS server, the source port would be a higher level UDP port. In this case, for example, 55,298. But the destination port would be unchanging because that's the network service listening port, in this case, UDP port 53 for a DNS server. Services will often require specific permissions on the host operating system. Now, we should try to stay away where we can from a normal user account that has a password that never expires or no password at all. Instead, if possible, we should configure network services to use a managed service account. Now, in the Windows environment, this is a special type of account that is designed for use by services where it has a complex password that will change automatically on a scheduled basis. Here on a Windows device, if we look at the running services, and if we were to double click on one and open it up, in the properties we would see a logon tab, where we can determine whether the service logs on with the local system account, whether it interacts with the desktop, or whether it's configured to use a user or a managed service account. Now, one thing to watch out for is the temptation of using an administrative type of account that has way more permissions than the service really needs. Required services are configured in the underlying OS with permissions according to the principle of least privilege. This means that we only assign enough permissions for the service to function properly and no additional permissions are given. We should also configure services to control incoming traffic sources. So, for example, if we have a Linux host that's managed through SSH, we might require that SSH traffic to come from a known and trusted IP network range, maybe a subnet where the administrative stations exist. This can also reduce discoverability when a malicious user is performing network scans over the network. We should also enable encryption and authentication wherever possible. Now, this can be application specific, such as when we configure an SSL or TLS certificate, for example, for a website, POP3 mail server, or an SMTP server. However, we could also have encryption and authentication at a much more general level in the form of IPsec, regardless of higher level protocol used. Hardening a host means disabling unused services. At least that's one part of hardening a host. So we can harden a host by blocking unused ports and services. And of course, if they're disabled, then they're not running in the first place anyway. We can also configure services in some cases to use a non-standard port. Now, you might do this, for instance, on a web server so that when someone types in the address of the web server in their web browser address bar, they also have to add a colon and then the port number you've configured. Now, web servers normally listen on TCP port 80, or if it's secured, port 443, but you could change it to a non-standard port. That also makes it more difficult for a malicious user to scan the network and map it out based on what services they think are running, because you're not using the normal service port numbers. Another way to harden a network service is to take log files resulting from a specific service and storing them on a different host. This is important because if the host on which a service is running is compromised, then the log files are meaningless. They could be wiped, their contents could be forged, and so on. It's always crucial that we apply the latest updates to the service and the underlying operating system hosting that service. Some services can also be throttled. Now, this might be true with some replication services that are designed for file transfer between hosts. The great thing about this is if we configure throttling, it prevents monopolization of resources like CPU utilization or network bandwidth. Network service hardening tools include some built-in items that you'll find in some operating system environments. So an Active Directory domain environment would use group policy to centrally configure settings on devices. So we could use group policy to centrally disable services, potentially for thousands of computers joined to the domain. So in this example, I'm in the group policy management tool for my Active Directory domain. I'm going to right-click on the default domain policy GPO on the left, and I'm going to edit it. The goal here is we're going to disable services centrally using group policy. Now, you might say group policy is not a security hardening tool. Well, it can be. It depends how you use it. We don't want to get into the mindset of thinking only third-party tools are useful for hardening because that's definitely not the case. So here inside this GPO, I'm going to go into computer configuration on the left. I'm going to expand policies. I'm going to expand Windows settings. And there are a number of things I could look at here. For example, if I go into security settings, well, naturally, I have a lot of security settings related to things like the file system, the Windows firewall, public key policies for PKI, and so on. But one of the things you'll see here under security settings on the left is system services. And if I click that on the right, I get an alphabetical listing of services. So maybe what I'll do is click in that list and press R and go down to remote registry. Now, if I know that we don't need the remote registry service running, we don't depend on it for any of our tools, then I might turn that off to prevent remote access to the registry on a Windows host. So if I were to double click on it, I could define the policy setting and either set that service to disabled or manual. Now, once I've done this, group policy would have to refresh on machines affected by this group policy object. Now, that can take a couple of hours. In some environments, it really depends on your environment and how you're structured. Other ways to harden a device as per network services are to use other tools like Microsoft System Center Configuration Manager or SCCM. SCCM can be used to apply security baselines to Windows and Linux device collections to make sure they align with organizational security policy. We might also use Microsoft PowerShell Desired State Configuration, or DSC, which can be used to harden both Windows and Linux hosts. Network services apply at the application layer primarily with higher level protocols such as Hypertext Transfer Protocol or Secure Shell. Now, even though these are higher level protocols that might apply to layer 7 of the OSI model, the application layer, that doesn't imply that it involves user interaction. In this video, we discussed network services.